So what we're going to do is we're going to start with what you should already know. Which is the basics for trigonometry. All right, so a couple very basic things. First of all, when I work with triangles, the side across, the opposite side is always labeled as the little letter across from the angle of that. So A is over here, B is over here, and C is over there. Okay, so there's first very basic. Now, we are going to work with sine, cos, and tan. How many of us remember sine, cos, and tan? Most of you should, right? Okay, so sine, cos, and tan is this. Sine is the ratio of the side opposite to the hypotenuse. Cos is the ratio of the side adjacent to the hypotenuse. Tangent is the side ratio of the side opposite over the adjacent side. So make sure that that's written down somewhere so you've got it beside you when you do this. So sine is comparing your opposite side to your hypotenuse. Cos is your adjacent side to your hypotenuse. And tangent is your opposite over your adjacent. So if I'm talking about sine of angle A, that means I'm looking at the ratio of the side opposite over the hypotenuse. What is the side opposite to the angle A in this case? Side A. That's right. And what's the hypotenuse? C. How do I know where the hypotenuse is? It's always the largest side and always across from the 90 degrees. That's right. That's always your hypotenuse. So then if I'm talking about the cos of A then, what's the side adjacent to A? What is it? No. Okay, there's two, correct? There's two that are next to this. One is B and one is C. But we've already identified C as being what? Therefore, B must be the adjacent side in that situation. So B over C like that. Okay? And then the tangent of A is the side opposite from A, which is A, over the side adjacent, which is B. Okay? Let's do the same thing with B now. Would B have the same ratios? The sine of B. What's the ratio of the sine of B? Which side is opposite angle B? B. The side across from angle B is the opposite, which is over here, which is B. So this is B over my hypotenuse, which stays the same as C. Right? What's the side next to angle B? The adjacent side. A is. So this ratio is A over C. And then the opposite again is what? B over A. The tangent ratio would be B over A. Okay? Questions? How many of us forgot this from last year? You? Okay. All right, so we'll look at all of these scenarios in a minute. Now, you will always be given 2 of the 3 pieces of information in order to solve. You don't have to solve anything without 2 of the 3 pieces of information. So you're always going to know either an angle at a side, or the measure of 2 sides, or measure of all 3 sides, whatever. You're going to know 2 of the 3 pieces of information. If you look in this right here, I've got an angle, a side, and a sine. I'm going to know two of those three pieces of information in order to solve for the third piece. All you are going to be expected to do is solve for the missing sides and angles in a right triangle. That's all right angle trig is. Can you find the missing side and missing angle? That's how that works. All right, so let's look at a couple examples.
So will you give us like the formulas?
It's on the speaker.
Two cats having an orange and held hand.
For that.
I don't think so.
So what was another one? Okay. All right. So let's say that this is 5 here. Okay. And this is 4 right here. All right. So the first thing I want to do is, what pieces of this triangle am I missing? On the bottom of it, which is side B. Missing that, right? What else am I missing? Which angles? A and B. I'm missing angles A and B. So when I approach these questions, I do it the same exact way every single time. I use the given information to help me solve it. Okay? So I am going to only use the 4 and 5 to solve all 3 pieces of information that I'm missing. So here's how this works. First things first. How would you suggest that I solve for this missing side?
5 squared, take away 4 squared.
Awesome. And what is that called again?
Pythagorean.
Pythagorean theorem. All right, so that would be the very first thing that I would do. Okay? Now, I'm going to tell you something here. This triangle is called a right triangle. Okay? Why is it called a right triangle? 9 degrees. Did you know that this triangle is also called the 3, 4, 5 triangle? No? You want to know why it's a 3, 4, 5 triangle? Because 3 squared plus 4 squared equals 5 squared is the smallest whole numbers that satisfy Pythagoras' theorem. So after knowing that, what do you suppose b is?
3.
It's 3. So let's solve for it. B squared plus 4 squared equals 5 squared. B squared plus 16 is equal to 25, right?
Yeah.
How do I get b squared by itself? Take away 16, so b squared is equal to 9. And then how do I get b? Square root, both sides. That gives me b is equal to 3. So there's the first thing that I solved for. Okay? Now, I want to solve for angle A. This is the part of the question that's going to cause you grief. All right? Because I'm looking for an angle. And there's something special you have to do when you look for an angle. So the first thing that I do, again, I try to recreate this, get off the wall, every single time doing the same thing. I write out my trig function first with all the information, and then I find the one that I don't have. So let's say I'm looking for angle A right here. The first thing that I do is I have to determine, is it sine, cos, or tan to solve it. That's the first thing I have to identify. So how do I do that? I look at the information given to me, and I work with it. Where is 4 in relation to A? It's the opposite. Where is 5 in relation to A? Hypotenuse. Which one of the 3 trig functions is opposite over hypotenuse? Sine. So now what I do is I write this out. Sine A equals side opposite over a hypotenuse. So my side opposite is 4, my hypotenuse is 5. Now here's where it gets a little tricky. You just have to remember one thing, okay? How do I find angle A? Rex? You did. Thanks, Rex. So that's exactly what you have to do. You need to use your second function when finding an angle. So you're going to go second function sine 4 divided by 5 and hit equals.
I'm just 53.
Well, it has to equal 180, right? So,
Yeah, mine is 53.
Okay, how many of you got 0.927 on there? You did? Okay, look at the top of your calculator. Your calculator is in radian measure instead of degrees. So you have to change it to degree mode. Is there anybody else that got 0.9 on their calculator when they did this? Yeah, reset your calculator, change it to degrees, change it to degrees.
Alright, now I get 53.1.
Okay.
Yeah.
BRG, sure it's degrees.
No, I can't. My calculator won't give me an answer. Like if I want to use any of those, I have to pay for myself first, and then yeah. My other calculator doesn't do it. Shit.
Okay, if you're chatting and you got it right, find that next angle B and don't do it with 180 degrees. Find it using trig.
I know, but what,
Anybody else?
My calculator here. Yeah. And yes. Okay. Because that's what I don't use it's fine. Shift and then.
Okay, so what was the answer here? And again, because you're using this value, I would suggest you do it to 3 decimal places. So it's 53 point what? 130. 130. So we're gonna leave that like that. All right. Now, let's use. Let's find out B now. Where is 4 in relation to the angle B?
adjacent.
Adjacent. Where is 5? Hypotenuse. So which trig function am I talking about?
Negative cosine.
So I go cos a B, and again you write this out every time so that you know that you're doing this right. Cos B is 4 over 5, B is equal to
36.87.
870. Okay, now I use my knowledge of triangles, okay, and I add these two together, and what should they add up to? 90, because the other angle is 90, and they should add up to 180. So this section, you should be able to prove that you've got everything right. You can check it before you hand it in. This is a section that you should not make errors in on basics, okay? Any questions about this so far? All right. A couple others. Let's look at page 39. Housing contractor is required to build a roof on a house with a slope 38 degrees from the horizontal. So a roof on the house 38 degrees. Additionally, the peak of the roof is to align with the center of the end walls. The house is 16 meters wide and has that are 4 meters high. That's not really a word well, but the house is 16 meters wide. So make that 8, because we're only talking about half the house, right? And then 4 high. Justin, you have a question?
No discussion.
Okay. All right. Oh, we got that a little bit wrong, don't we? The peak is, says that, I think that's
The house
it
is
has,
4 meters.
has walls that are 4 meters high. That's the missing. So right down here, this is 4 meters, so we gotta find this right here and find out how high that is. Alright, so long and short of it is one of the things that you're going to, as you can tell, even though this one was just worded poorly, one of the things you'll struggle with is drawing these diagrams. For right now, I need you just to be able to use triangles that are given to you to solve it. Okay? But eventually you'll have to draw them. So they want to find out how high the house is. So I need to find x here. Okay? So to find x, where is x in relation to 38?
Opposite.
Opposite. Where is 8 in relation to 38? Adjacent. So which one is opposite over adjacent? Tangent. So I rewrite it out. Tangent, 38 degrees is equal to the side opposite, x, over the side adjacent, which is 8. Okay? How do I solve this guy now? How do I get x by itself?
Multiply.
What's that?
Multiply by
Justin?
multiply by 8.
Alright, right now I am dividing by 8. So if I divide by another 8, it's going to stay, right? So I have to do the opposite of that, which is multiply. Okay, so I can look at this in 2 ways. I can times both sides by 8, in which that would cancel and leave me with 1, x, okay? Or I can just say that I'm going to multiply the 8 up to the other side to get rid of it from the x side. Either one, whatever makes sense in your head, you just go with that. So how do I solve this then? I take 8 and I times it by 10, 38. So let's do that on our calculator now, please. 8 times 10, 38. Three decimal places, please. 250. Okay, perfect. Okay, so how high is the house?
10.25.
Plus the 4 meters. 10.250. Okay? Any problems with this so far? So I've shown you the hardest thing is to find angles, so I've shown you that already. The second thing is just to solve for that third. There is one other, I'll draw it out for you right now and show you how this works. And then you basically have everything you need for 3.1 and 3.2. So on this, the last part and the part that people find difficult is I'll do this. Okay, so I want to find out what the x value is, what the measure of the hypotenuse is. Okay, where is 8 in relation to 40 degrees? Adjacent. Where is x in relation to 40 degrees? Hypotenuse. Which one of the trig functions is adjacent and hypotenuse? The cosine of it. So let's write this out. Cos 40 degrees is equal to the side adjacent, which is 8, over x. Okay? So now I need to solve for x. Suggestions. Say that again?
Divide
40 by 8.
Divide, you divide 8. So 8 multiply. And then it would be 1x. And
Right, 8 by, but then you have to divide 8 to the cos.
You got us stumped, Mr. Navy.
Cos 40 divided by
What is it?
cos 40 divided by
8 divided by the cos of 40.
Alright, so we have two choices then. We have 8 divided by the cos of 40, and we got the cos of 40 divided by 8. I'm gonna show you the easiest, most simple way to look at this without confusing you. All I simply do is change those two. Change those two. I'm gonna move the x up to here and move the cos of 40 down to there. That's the non-mathematical, simple way of looking at that. It'll work every time. So I get x is equal to 8 divided by the cos of 40. That's the easiest way to do it. When you are set up in that situation where your x value or the value you're looking for is on the bottom of the fraction, just move it to the other side. Now the mathematical way of doing it is I times both sides by x and I divide both sides by cos 40. Don't need to worry about that. Just switch these two. When the x is on the bottom of the fraction, switch it. That's it. Okay? What is 8 divided by cos 40? All right. Now, how can I quickly tell that I'm probably on the right track or not?
Because it's
X? It's higher than 8. Why would that matter? Because why? Yes. Well done, Rex. You answered every question right down one. Okay? The number was larger than 8. That's a first good sign. Why? Because the largest side, the longest side, is always a hypotenuse and always across from the 90 degrees. So if it isn't, then you know you have an error somewhere in there. And when I get into law of sines and law of cosines with you in grade 11, that's how I check. That's how I tell everybody to check. Make sure the shortest side and the smallest angle are across from each other, and the largest side and the largest angle are across from each other. And it's foolproof. It'll work every time. All right? How many of us are better than what we were 20 minutes ago? Okay? Who's still not sure about this trigonometry? You're still struggling with it, Jamie?
Yeah.
What part of it is bothering you?
All of it, yeah. All the way to the family, the son,
Okay, so it all goes back to what we started with, Jamie. Right here. To find the measure of an angle, I have to compare the lengths of two sides in order to get it. And depending on what I'm given, I have to use sine, cos, or tan. So if I'm looking for this, no more talking. If I'm looking for this angle right here, I'm going to give you two of the three sides. And depending on what the sides are, all right, I have to determine whether I use one of these three. You follow what I'm saying so far? Okay, so if I'm given this side and this side, I look at the angle and I say, okay, well that's the opposite side and that's the hypotenuse. So I need to use sine to get it. If I give you this side and this side, well that's the side opposite, that's the side adjacent, I use tangent. If I give you this side and this side, that's the adjacent, that's the hypotenuse, I'm going to use cos to do it. And I put them in wherever I need to. So if it's an angle, I write it here. If it's a side and a side, I write them here and here, depending on where they're located compared to the angle I'm talking about. Does that make more sense? Okay? So when I looked at this first question that I drew up here, all right, I was talking about this angle. Well, I gave you this side and this side. That's the side across from it, which is opposite. That's the hypotenuse. So I write it as sine of angle A is equal to 4 divided by 5. That's the ratio of the opposite to the hypotenuse. And then I have to use second function sine and then divide it to get that. Okay? Now when I was talking about B, this side is actually the adjacent side. This is still the hypotenuse, but that's the adjacent side. So now I go cos of B, because that's adjacent over hypotenuse. Follow? And then I do second function cos again, and I get my angle that way. Okay, did you even try it? Did anybody else need anything? Yeah, Brock.
I didn't figure out like which one's adjacent, which one's opposite.
Based on the angle.
If you have.
My angle's right here, right?
Yeah.
Where's the side opposite? Where's the side adjacent? B. If I'm talking about this angle right here, where's the side opposite? And where's the adjacent side? All based on the angles. Does that make sense?
There wasn't an angle, I didn't know how, I was trying to hypotenuse.
Yeah. So it's based on which other angle you're working with in order to get that.
There'll always be 90-degree angle at it.
Yes.
Yeah, when you have to find the angle, like not like the side, like for the angle, you can like use any of the information, right?
Yes.
Okay.
But just use your given information.
Yeah.
So that you don't make an error twice. Okay. So this is, going back to this question right here. I found this angle right here first, 53.130. The reason that I didn't subtract it from 90 to get that angle is what if I had made an error on it? If I made an error on this, then they both would be wrong. So that's why I found this using sine and I found this using cos. And then I checked to see if they're right by adding them up to 180 degrees. Okay? Martin?
What do you use the second sin and the second cos?
Anytime you're looking for the angle itself.
And when you're looking for the side, you use
Just normal sine, normal cos. That's right. Yeah. Good question. Okay? All right. You gotta work on 3.1 and 3.2. We'll do that today and tomorrow.